All right, we're back. We're on the top of 279. We're going to keep rolling. So in the last video, we talked about finding limits that are infinity, not limits as x approaches infinity. X is approaching a finite number, and as you do that, you're either going to infinity, negative infinity, from the left or the right. Just depends. Wait, that was all wrong. Whatever. Yeah. So as you approach a single number, the value will shoot up or it will shoot down to infinity or negative infinity, depending. So here's the official definition, which we've talked about a couple of times. A function f of x has a vertical asymptote at x equals a if the limit as x approaches a from the left is infinity or negative infinity, or, not and, or the limit as x approaches a from the right of f of x is infinity or negative infinity. Notice there's a bunch of things here. X doesn't need to be in the domain. In fact, x will almost never be in the domain of the function because the function usually doesn't exist there because you're usually trying to divide by 0. So it won't be in the domain. You don't need it to happen from the left and the right. It could be the left or the right. So let's do this problem because it's designed to, confuse you a little bit. And that's good. So here we have a piecewise function. We're going to try to find the vertical asymptote. So you got to think carefully about this. Think like, what's happening on the specific domain for each branch, right? So for the first branch, so let's just say, let's say 1, 2, 3, right? For the first branch, we're only interested in x being less than or equal to -2. But we're going to make the full sign chart because each of those factors has something to do with the signs on the sign chart. So here we go. What's our function named? F. All right, sign chart for f. We only care about x less than or equal to -2, but we've got -4, -3. What? Ooh, I don't even know what I just did. Somehow I made it like grow and I could like, I don't know. I was like zooming in. I was like Sherlock Holmes. I had like a magnifying glass. Magnifying glass. And then what else? 5. Okay, so we're only really interested in this way, right? That's all we care about is x less than or equal to -2. But let's see what we get. If I take negative infinity, negative billion, why do I keep trying to use negative infinity? Negative a billion, negative, 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 3 negatives, negative overall. Everything is first degree, so it's always going to alternate, so I'm just going to do it. Okay, so what's happening at -4? The limit as x approaches, so I only need it from one side, so I'm only going to do one of them. Limit as x approaches -4 from, let's say, the left of f of x is, so x equals -4 is one of the zeros of the denominator, so I know there's a vertical asymptote there. I'm just trying to like prove it, right? So the limit as I approach -4 from the left is negative infinity, so therefore x equals -4 is a vertical asymptote. Okay, proved it. That's all we needed. What's happening at x equals 5? If we were allowed to keep going until we got to x equals 5, then x equals 5 would have been a vertical asymptote. But in this case, it's not because we are arbitrarily, for really no great reason, just stopping at -2. We're just stopping there. There's nothing we can do. All right, let's move on to branch number 2. Okay, so we're going to do the complete sign chart, even though we're only interested between -2 and 3. So let's do this. All right, so the zeros of everything. So I got to put -2. I got to put 0. And I got to put +2. Okay, we're only interested between -2 and 3. So that's like here and then here, I guess. Right, and we're only interested in this interval. But what's happening on this interval? All right, so if I plug in -1 billion, because I have to do that, because if I don't do that, then my signs risk getting off, especially off track, especially if I'm going to just like use that idea of like, oh, they're all first degree, so it should alternate. So you want to fill in your complete sign chart, otherwise like the pattern can just, go wrong. So -1 billion, negative, negative, negative. 3 negatives make a negative. Negative. Everything's going to alternate now. So I'm going to test -1, but I already know I'm going to get positives. So I get a negative on the top, I get a positive one, I get a negative. So negative, negative is positive, which I was expecting. And then it's going to alternate because they're all to the first degree. And then like this. Okay, so big question here. Is x equals -2 a vertical asymptote for this, right? So it's not in the domain. It is in the domain, actually. It's in the domain because of up here. So x equals -2 is in the domain. But if it wasn't in the domain, would it matter? I think it would not matter, right? I mean, look at when we did branch 1. X equals -4 is not in the domain, but it's a vertical asymptote. So the definition is the limit as x approaches that number is infinity or negative infinity. The limit as x approaches -2 is infinity if we approach from the right, which is where we're supposed to. So I'm going to say it down here, I guess. The limit as x approaches -2 from the, this is a surprising one, right? Because it's weird. It's like an endpoint. Can an endpoint be a vertical asymptote? It turns out, yes, it can. Of, what are we called? F of x is infinity. Therefore, x equals -2 is a vertical asymptote. And then similarly, I'm going to approach this one from, it doesn't matter. I'm going to approach from the right. Could have approached from the left and got negative infinity. I'm going to approach from the right and get positive infinity. Therefore, x equals 2 is a vertical asymptote. All right, so two down. Branch number 3 up here. So got to put all the zeros. All right, -5 and -2. Okay, I'm going to finish the sign chart, but -5, -2. But we don't care about any of these, right? Because we only care when x is greater than or equal to 3. So like here. So you can't get any vertical asymptotes from this. I mean, let's finish the sign chart, but like you can't get any vertical asymptotes on this branch on the domain on which we're interested. There are vertical asymptotes, right? Like -1 billion is positive in the numerator, negative, negative. So positive, then it's going to switch. Then positive again. What is going on? But no vertical asymptotes on this domain. So I'm going to say no vertical asymptotes on x greater than or equal to 3, because that branch would have had vertical asymptotes. They just didn't make it. So all my vertical asymptotes are, let me do the like good student thing where I just highlight them, right? So this, and this. Those are my vertical asymptotes. Didn't get any when x was greater than or equal to 3 because on that domain, there were none. All right, let's see. What weird property does this thing have? All right, so let me investigate 1 over x, right? So 1 over x. So I'm just going to say this 1 over x. I got, there's a 0 the denominator there. I'm only interested in x being less than 0. So I kind of know this is going to be a vertical asymptote because it's 0 the denominator. That's not also a 0 the numerator. So it's going to go negative, positive. I just want to like justify it, right? So the limit as x approaches 0 from the left of 1 over x is negative infinity. Therefore, x equals 0 is a vertical asymptote. Okay, so now the question though is like, what's the weird property? Well, look at this. X equals 0 is a vertical asymptote, but f of 0 is 2. It's defined, the function is defined at and intersects its vertical asymptote. So let's write that. It's defined at and intersects its vertical asymptote. So this will only happen for piecewise functions, but it can happen, right? So if we create a graph of this, trying to like, here we go. All right, let's create a graph of this thing. Oh my God, my vertical lines. All right, not terrible. So it's 1 over x. Ooh, it's the pressure. I know everybody's watching, you know. Got this. Because I'm gonna use color here. Can't really tell. It's not really that much better. If I do lighter color, lighter color is better, vertical asymptote. And then 2 plus 3x, right? So it's going to be like here, and then here. This is the graph of f of x. Crazy looking, right? So it's a function that intersects its vertical asymptote. You probably are under the false impression that that can't happen. It doesn't happen for any well-behaved functions, but a not well-behaved function, it can definitely happen. All right, and then let's finish this page because we're very close. I need to give examples of functions for which each of the following is true. So you go to your mental bank of functions and you start thinking like, I need a function that just where the limit doesn't exist. So there's a lot of options. For example, what if I just take 1 over x and shift it 3 units to the right? So I could do 1 over x minus 3. I know that that's going to work. I also know that the absolute value of x minus 3 over x minus 3 is going to work. There's an infinite number. Both of those are good, right? So for the first one, you get negative infinity from the left, positive infinity from the right, because I memorized it and I just shifted it, so I know that. For the second one, you get -1 from the left and +1 from the right, and then it doesn't even exist there. It's a jump discontinuity. That's a famous function. You should know it. All right, so I'm going to go with that. Next one. What can I modify the previous ones? I think I can. I'm just going to say that f of x is 1 over the quantity x minus 3 squared. That does it, right? So you took the negative infinity, but you squared it. So it goes positive infinity, it's good. What would I do here? So here, I mean, why would I not just flip it, right? When you find a good thing, just keep using it over and over. There you go. I think that those are all good examples of what we're trying to accomplish. Could we have squared the first one? I feel like this one, I think if you just square it, it's not going to work. I think if you square it, you're going to get one from the left and the right. So that's too risky. Don't go with that one. Could I have done something else? What about 1 over the absolute value of x minus 3? 1 over the absolute value of x minus 3. It approaches 0 from the left and the right, but just the absolute value of x minus 3 approaches 0 from the left and the right at 3. So the reciprocal of that would be basically positive infinity. I think you could do that. So let's add that to the pile. So f of x is 1 over the absolute value of x minus 3. I think that'll work for you, right? So the denominator is approaching 0 from the positives in both cases. Like if you're from the left, you approach 0, but like positive 0. And then you square it and you get infinity. As you approach from the right, you get definitely positive 0, whatever that means. You square that. No, you don't square that. Positive 0, and then the reciprocal is infinite. So yeah, I think that works. All right, I'm going to cut this video here, and I will obviously be back to do more in the next video. I will see you then.